Welcome to BSc Statistics students. So in this class, I explain the changes in the elements of quotient matrix A, in which I have discussed already case 1, and in the case 2, I have discussed the feasibility condition. Now I discuss optimality condition in case 2, right? So this is what already I have explained case 2. There are two particular changes in case 2. Two particular conditions are going to be changed, which one is feasibility and another one is optimality. This is case 2. Case 2 is if AK belongs to B, then the changes in ARK belongs to the basis matrix B, then current optimum solution and optimality condition both are affected. In this case, I already explained that how the feasibility, the optimality in the sense optimum solution in the sense feasibility XB and optimality are going to be maintained for any kind of discrete changes in delta ARK, that is ARK, that is delta ARK. Right, I have already discussed the feasibility. Probably you can easily follow that. The condition for maintaining the feasibility I have already discussed, and now I discuss the condition for maintaining the optimality. You see, this is what the today's topic. In this class, the topic, the condition for maintaining the optimality of the solution. Okay, you can refer. This is case 1. In the case 1, delta RK limits are the range is nothing but maximum of minus xbi by qi, where qi greater than 0, less than or equal to delta RK, less than or equal to minimum of minus xbi by qi less than 0. This is what the I'm sorry, the feasibility condition for maintaining the feasibility condition, the range of the discrete changes delta RK. So now I discuss condition for maintaining the optimality of the solution. If any discrete changes of any particular changes in ARK, that is delta ARK is the change, additional amount is going to be added to the value ARK, coefficient ARK, then how to maintain the optimality. So for maintaining the optimality of the solution, we must have to consider Zj star minus Cj star is greater than or equal to 0 for all j is equal to 1 to n. That is going to be established with the formula, and it's going to be a condition is going to be obtained. You see, what is Zj star minus Cj star? It is nothing but Cb, actually B inverse now star. Therefore, for that element for which the vector, it consists of one particular vector, and the change in that vector we are observing. So therefore, Cb B star inverse multiplied by Yj. The formula of Zj is nothing but Cb B inverse Yj. So Zj star is nothing but Cb B star inverse Yj minus Cj as usual. Cost is not going to be changed. So therefore, Cj star is nothing but Cj. The cost do not change, right? In this particular case. So where B star inverse is nothing but already I have explained that it is EB inverse multiplied by Yj minus Cj. That is B star inverse equal to EB inverse. We have substituted. Now B inverse Yj is nothing but Yj. B inverse Yj is nothing but it's a value as going to be obtained on Yj in a particular vector, the column vector, right? Now what is CB? CB is nothing but the column vector which consists of m coefficients of the cost function for the basic variables, that is CB1, CB2, CBK and so on, CBK and so on, CBM. So because of in the basis we have m variables, m by m matrix, m variables. For m variables, m costs, cost coefficients, that is CB1, CB2, CBK and so on, CBM. And E, already I have explained in the previous class 1, this is a identity matrix except one particular value vector, one column vector is going to be changed. The change is already discussed. 1 0 0 and so on, 0 1 0 0 and so on, then and so on. the kth vector, it's going to be considered as minus lambda 1 by lambda k, minus lambda 2 by lambda k, and so on, 1 by lambda k. This is what the bk star element, kth element, and so on, minus lambda m by lambda k, and so on, 0, 0, 0, 1. So these are the m column vectors, and which consist of E. E is nothing but identity matrix multiplied by Yj. Yj vector is which takes the values y1j, y2j, and so on, ykj, ymj, minus cj. So this is what the calculation. In this calculation, if you multiply these two, what you will get? Only the one particular value is going to be considered, that 1 into yj. I'm multiplying row and column, 1 into yj, remaining zeros, 0 into 0 into, and so on, multiplied by minus plus, here minus lambda 1 by lambda k into ykj, plus and so on, 0 into ymj. So 0. So therefore y1j minus lambda 1 by lambda k into ykj. Similarly, in the second column, by multiplying second row and this column, what you will get? 0 into this, 1 into y2j, this is y2j, and so on, minus lambda 2 by lambda k into ykj, and multiplied by yk, that is multiplied by ykj, lambda 2 by lambda k into ykj, and so on. This is for this row, only one value, 1 by lambda k, 1 by lambda k into ykj, that is ykj by lambda k, ykj by lambda k, and so on. Now this is, if you multiply last one also, minus lambda m by lambda k into ykj, multiplied plus ymj, 1 into ymj, minus lambda m by lambda k into ymj, minus cj, in which all the values are similar except the kth element, ykj by lambda k, remaining all y1j minus lambda 1 by lambda k into ykj, y2j minus lambda 2 by lambda k into ykj, and so on, ymj minus lambda m by lambda k into ymj. So if you multiply with cost cb1, this particular vector, cb1, cb2, and so on, cbk, cbm. So cb1 multiplied by this y1j into lambda minus y1j minus lambda 1 by lambda k into ykj, plus cb2 multiplied by y2j minus lambda 2 by lambda k into ykj, plus and so on, cbk multiplied by only ykj by lambda k. This is only the different one. cbk multiplied by ykj divided by lambda k, plus and so on, plus cbm multiplied by ymj minus lambda m by lambda k into ykj, and last one minus cj, the cost. So we have to now multiply and get in a particular form, right? So observe here, summation. This is what I'm doing is 1, 2, and so on, this one, mth one, except this kth one, remaining all will be in the similar way. That is what we are writing. We are taking in one addition, one summation. Summation I is equal to 1 to m, I is not equal to k. Only the value which is not considering this one, I is equal to k, we are not considering. That is why we have written I is not equal to j, I is not equal to k, right? So cbi, I is equal to 1, I is equal to 2, I is equal to m, except I is equal to k. Right? cbi multiplied by yij, y1j, y2j, and so on, ymj, yij minus lambda I by lambda k, lambda 1, lambda 2, and so on, lambda m, lambda k is common, lambda I by lambda k into ykj, ykj is a common value. So this is what in one summation. Another one, plus cbk ykj by lambda k minus cj, last one, this one and the last one, remaining all the terms in the summation. I is not equal to k. So let you consider, let you separate here, we separate this one. What you will get? Summation I is equal to 1 to k, cbi into yij minus this, no, not equal to this is not here, and minus summation I is equal to 1 to m, I is not equal to k, cbi into lambda I into ykj divided by lambda k, okay, and plus cbk ykj divided by lambda k minus cj, right? While you go to the next step, if you go to the next step, then it will be summation I is equal to 1 to m cbi by ij, I is not equal to k here, and summation I is equal to 1 to m, I is not equal to k. CBI, this lambda I. Lambda I is nothing but beta ik delta rk. That is lambda I. Beta ik lambda delta ark, that is lambda I multiplied by ykj divided by 1 plus lambda k. We are substituting lambda I, lambda k values. Lambda k, we know that already we have discussed in the previous case. Lambda I is beta ik delta ark, lambda k is 1 plus beta kk delta ark. That's it. That's the only change in lambda and lambda k. Remaining all the values are same. That is lambda I is equal to k is different. Lambda I remaining values are same. Here I is equal to 1 to m is true for this also. Beta ik delta ark divided by 1 plus beta kk delta ark. Plus this is cbk ykz divided by lambda k value is 1 by 1 plus beta kk delta ark minus cj. Right. Now what we are doing here, what I am doing here, the next step, you see the next step very carefully. It is very crucial, right? In which wherever I'm having the CBI and YIJ, the values I'm taking here. It's a small kind of consideration is also here. One may not understand how this is going to be done, right? I is equal to 1 to m. You see, I is equal to 1 to m. That is, I is equal to k also included here. Where it is CBK YKZ. This particular term we have included here. That is, you have to carefully read out this. Summation I is equal to 1 to m CBI YIZ, that term, all the terms of CBI into YIZ is included here, which are included here, minus remaining these two terms also multiplied here. These two terms also, that is not multiplied actually, get into the one particular summation. It was considered into one summation. You see, summation I is equal to 1 to m CBI beta ik, that's what we have considered here. If you do minus and plus, then you will, one particular term, plus term will be here and minus term will be here. Have you understand this? That is the reason minus. The plus term is going to be included here, minus term will be left here. That is what summation I is equal to 1 to m CBI beta ik delta ark ykz divided by 1 plus beta kk delta ark. So all the terms are mixed, combined here. Minus cj. I is equal to 1 to m as usual. All the terms included. There is no separate I is not I is equal to k term here. That is in the summation. Now there is no I is not equal to k because it is also included here. That is what you have to understand. They are very similar terms. These are all very similar terms. These two are the same kind of similar terms we have. If you multiply and divide with delta ark and ykz etc., they all will take in one particular value, right? So therefore minus this is the entire part except cj. Remaining are which included in one particular summation. Summation I is equal to 1 to m CBI YIZ minus summation I is equal to 1 to m CBI beta ik and delta ark ykz divided by 1 plus beta kk delta ark minus cj. So now you take minus cj here. So it is nothing but summation I is equal to 1 to m CBI YIZ minus cj and remaining the term summation I is equal to 1 to m CBI beta ik, that can be written as CB beta k in the vector form. CB beta k in the matrix form, vector form, right? CB beta k multiplied by delta ark ykz divided by 1 plus beta kk delta ark. Okay, what is this? This is Zj minus Cj. Zj is nothing but summation CBI Yij. So Zj minus Cj minus Ykj delta Ark Cb beta k. Delta Ark Ykj, I am writing Ykj delta Ark Cb beta k divided by 1 plus beta kk delta Ark. This is what is this? Zj star minus Cj star. You see, you refer here. This is what Zj star minus Cj star. The value is this. Now you have to apply the optimality condition. To prove the optimality condition, that is to maintain the optimality condition, it is required to have Zj star minus Cj star is also should be greater than, is also to be maintained greater than or equal to 0. So that is what remaining all greater than or equal to 0. That is only the change in the this particular term. So therefore you have to maintain this, to maintain this, it is that J star minus Cj star also to be proved as greater than or equal to 0. Right. Now the optimality condition satisfies if J star minus Cj star greater than or equal to 0. Right. So we have calculated J star minus Cj star, that is Zj minus Cj minus Ykj delta Ark Cb beta k divided by 1 plus beta kk delta Ark is greater than or equal to 0. So therefore you consider this particular term, take this term right hand side, Zj minus Cj greater than or equal to Ykj delta Ark Cb beta k divided by 1 plus beta kk delta Ark. Right. So and then you take this particular term the left hand side, and so that you multiply with Zj minus Cj. Zj minus Cj into 1 plus beta kk delta Ark is greater than or equal to Ykj delta Ark Cb beta k. Now you take this particular term the left hand side. So therefore Zj minus Cj, you multiply with 1 here, Zj minus Cj into 1, Zj minus Cj plus Zj minus Cj into beta kk delta Ark. This particular term take into the left hand side, that is minus here plus minus, if you take the left hand side it becomes plus, minus it becomes minus, sorry, it becomes minus. So minus Ykj delta Ark Cb beta k is greater than or equal to 0. So in which you consider the terms of delta Ark, because we have to calculate the range of delta Ark. So therefore here we have delta Ark, here also we have delta Ark, take a common, and so that here remaining values are Zj minus Cj beta kk minus here Ykj Cb beta k into delta Ark is greater than or equal to, you take this particular Zj minus Cj right hand side, so therefore it becomes minus of Zj minus Cj. Now delta Ark, now you take this particular term right hand side, delta Ark is greater than or equal to minus of Zj minus Cj divided by Zj minus Cj into beta kk minus Ykj Cb beta k. This is what the condition. Now this condition is satisfies for two particular separate values, that is let you consider Qj is equal to Zj minus Cj into beta kk minus Ykj Cb beta k. You consider this denominator term Zj minus Cj into beta kk minus Ykj Cb beta k. You consider Qj. Then for Qj greater than 0, delta Ark is greater than or equal to minus Zj minus Cj divided by Qj. For Qj is greater than 0, delta Ark is less than or equal to minus of Zj minus Cj divided by Qj for Qj is less than 0. So therefore, now if you see the condition, that is the range of the delta Ark, to maintain the optimality condition, delta Ark must lies in between these two particular values. What is the first one is maximum of minus Zj minus Cj divided by Qj greater than 0 is less than or equal to delta Ark is less than or equal to minimum of minus Zj minus Cj divided by Qj less than 0. So that is the range of delta Ark. Hope you understand. This is what the optimality condition, to maintain the optimality condition, the range of delta Ark. So this is what the theory behind the feasibility and optimality condition. To maintain the feasibility and optimality condition, the ranges of delta Ark we have calculated, we have discussed in these two sessions. So these are the two particular sessions which I have explained, that the case 2. The case 2 is nothing but if AK belongs to B, the basis matrix in which ARK we have considered and delta Ark is a change, and there we have calculated the range of delta ARK to maintain feasibility and optimality. In two separate classes I have explained this. Hope you have understand. And case 1 I have explained in another class. So total 3 classes I took for explaining the these three particular important concepts for the changes in the coefficient matrix, elements of the coefficient matrix A, that is Aij, in the post-optimal analysis. Thank you so much.